In this chapter we studied unit second, trigonometry. Three, part B. So here first property, property 7. Here first property is sin inverse of x is equal to cos inverse of root 1 minus x square is equal to tan inverse of x upon root 1 minus x square, which is equal to cot inverse of root 1 minus x square upon x is equal to sec inverse of 1 upon root 1 minus x square is equal to cosec inverse of 1 upon x. So how to prove this property? So first is here given that let sin inverse of x is equal to theta, then x is equal to sin theta by definition of inverse function. Then now we have first upon we find out in terms of cos inverse. So cos theta is equal to root 1 minus sin square theta, since root 1 minus sin square theta, hence cos theta is equal to root 1 minus, but sin theta is equal to x, means sin square theta means x square, hence theta is equal to cos inverse of root of 1 minus x square, since if cos theta is equal to y, hence theta is equal to cos inverse of y, hence sin inverse of x is equal to theta means sin inverse of x, hence theta means sin inverse of x is equal to cos inverse of root 1 minus x square, but cos square of x is equal to sec inverse of 1 upon x, hence cos inverse of this is sec inverse of 1 upon x, means 1 upon root 1 minus x square. Then cos inverse and sec inverse are proved. Then we find out in terms of tan inverse. So again tan theta is equal to sin theta upon cos theta, but here sin theta means x and cos theta, and cos theta is equal to root 1 minus x square, root 1 minus x square. Hence, by finding out this equation, then hence theta is equal to tan inverse of x upon root 1 minus x square. This is find out in terms of tan inverse, but tan inverse of x is equal to cot inverse of 1 upon x. Hence tan inverse of x is equal to cot inverse of 1 by x, means denominator वरती जाना 1 minus x square upon x. And we already have sin inverse of x is equal to, आपल्याला माहिती आहे की sin inverse of x is equal to cosec inverse of 1 upon x. Hence all these properties are proved. Hence from this equation from 1, 2 and 3 we get sin inverse of x is equal to cos inverse of root 1 minus x square, and tan inverse of x upon root 1 minus x square is equal to cot inverse of root 1 minus x square upon x is equal to sec inverse of 1 upon root 1 minus x square is equal to cosec inverse of 1 upon x. Hence these formulae are proved. Then we give next property. Then we give next property second, cos inverse of x is equal to sin inverse of root 1 minus x square is equal to tan inverse of root 1 minus x square upon x is equal to cot inverse of x upon root 1 minus x square is equal to sec inverse of 1 upon x is equal to cosec inverse of 1 upon root 1 minus x square. So first in terms of let cos inverse of x is equal to theta, then x is equal to cos theta. Now then sin theta is equal to root 1 minus cos square theta, because since sin square theta plus cos square theta is equal to 1, but sin theta is cos theta is equal to x. Since cos theta is equal to x, hence 1 minus cos square theta means x square. Hence theta is equal to sin inverse of root 1 minus x square. Since if sin theta is equal to y, then theta is equal to sin inverse of y. But theta is equal to cos inverse of x, since cos inverse of x is equal to sin inverse of root 1 minus x square. Means first property is root, but sin inverse of x is equal to cosec inverse of 1 upon x, and sin inverse of x is the cosec inverse of 1 upon x, means this root 1 minus x square. Hence this and this property are proved. Then we find out in terms of tan theta. Here for tan theta, sin theta is equal to this and cos theta is equal to x. Then we find out in terms of tan inverse. So tan theta is equal to sin theta upon cos theta, but sin theta is the root of 1 minus x square and cos theta is equal to x. Hence theta is equal to tan inverse of this, means tan inverse of root 1 minus x square upon x. Hence this property is proved. But since tan inverse of x is equal to cot inverse of 1 upon x, hence is equal to cot inverse of 1 upon x, means x numerator ला जाणार upon root 1 minus x square. Hence this property proved, and this property are proved. Then we prove that only this property, and also cos inverse of x, we also know that cos inverse of x is equal to sec inverse of 1 by x by this formula. Hence from all these, 1, 2 and 3, hence cos inverse of x is equal to sin inverse of root 1 minus x square is equal to tan inverse of root 1 minus x square upon x is equal to cot inverse of x upon root 1 minus x square is equal to sec inverse of 1 upon x is equal to cosec inverse of 1 upon root 1 minus x square. So hence these all properties are proved. Then third property is tan inverse of x is equal to sin inverse of x upon root 1 plus x square is equal to cos inverse of 1 upon root 1 plus x square is equal to cot inverse of 1 upon x is equal to sec inverse of root 1 plus x square is equal to cosec inverse of root 1 plus x square upon x. Then third, let tan inverse of x is equal to theta, then tan theta is equal to x. But we know that tan theta is equal to sin theta upon cos theta. Hence sin theta, but here tan theta is equal to x, so x is equal to sin theta upon cos theta, but hence sin theta is equal to x into cos theta. But we know that cos theta is equal to root 1 minus sin square theta. Hence is equal to x into cos theta means 1 minus sin square theta. And sin theta is equal to x into root, but here we get square. Sin theta square is sin square theta and x square is x square and this square is 1 minus sin square theta. This root square is root cancel on 1 minus sin square theta. Then solve this bracket, x square into 1 x square minus x square into sin square theta. But suppose sin square theta कॉमन घेतला तर ब्रॅकेटमध्ये काय 1 प्लस एक्स स्क्वेअर इज इक्वल टू दिस एक्स स्क्वेअर. हेन्स sin square theta is equal to x square upon this 1 plus x square. Hence sin theta is equal to this square root. X square root is x, and this square root is square root of 1 plus x square. Hence theta is equal to sin square x upon root 1 plus x square. Hence, and which is equal to, but sin square x is equal to cosec inverse of 1 upon x. Hence cosec inverse of 1 upon x means root 1 plus x square upon x. This is first equation, and sin square and then cosec square is proved. Then this is first equation is proved. Then we give the, say again we have sin theta is equal to x into cos theta, but sin theta is equal to 1 minus cos square theta is equal to x into cos theta. Hence this square is 1 minus cos square theta is equal to x square into cos square theta. Hence 1 is equal to x square cos square theta plus cos square theta. इथे मायनस साइन आहे, इथे गेल्यावर प्लस होणार, प्लस कॉस स्क्वेअर थिटा. आणि यामध्ये या दोघांमध्ये कॉमन काय तर कॉस स्क्वेअर थिटा इन ब्रॅकेट 1 प्लस एक्स स्क्वेअर. हेन्स कॉस स्क्वेअर थिटा इज इक्वल टू काय ना, इज इक्वल टू 1 अपॉन दिस 1 upon 1 plus x square. But here cos square theta, आपल्याला cos theta find out करायचं. So cos theta is equal to, it's a root, one's a root 1, this root is root 1 plus x square. Hence theta is equal to काय ना, cos inverse of 1 upon root 1 by definition of inverse function. But since we know that cos inverse of x is equal to sec inverse of 1 upon x, means cos inverse of x is equal to sec inverse of this upon 1, means root 1 plus x square. This is second equation. And cos inverse of this means this is proved. Then sec inverse of this. Hence only we have to prove that this cot theta, but also we know that tan inverse of x is already equal to cot inverse of 1 upon x by the formula. This is third equation. And from 1, 2 and 3 we can prove that all these equation tan inverse of x is equal to sin inverse of x upon root 1 plus x square is equal to cos inverse of 1 upon root 1 plus x square is equal to cot inverse of 1 upon x is equal to sec inverse of root 1 plus x square is equal to cosec inverse of root 1 plus x square upon x. Hence we prove all these properties. Then next property is property 8. Then in property 8, first property sin inverse of x plus or minus sin inverse of y is equal to sin inverse of x into root 1 minus y square plus or minus y into root 1 minus x square. Hence, first we do that let sin inverse of x is equal to theta and sin inverse of y is equal to phi. Hence, sin theta is equal to x and sin phi is equal to y. Now, but we know that cos theta is equal to root 1 minus sin square theta and cos phi is equal to root 1 minus sin square phi. Hence, cos theta is equal to root 1 minus sin square theta means x square and cos phi is equal to root 1 minus sin square theta. Sin phi is the y, so 1 minus y square. Now we know that sin theta plus or minus phi is equal to sin theta into cos phi plus or minus cos theta into sin phi. Since sin A plus or minus B is equal to sin theta sin A into cos B plus or minus cos A into sin B. Hence, sin theta plus phi, which is phi, is equal to or minus phi is equal to sin theta means x into cos phi. Cos phi is root 1 minus y square plus or minus cos theta means root 1 minus x square and sin phi is equal to y. So root 1 minus x square into y. Hence theta plus or minus phi is equal to sin inverse of root 1 minus y square plus or minus x into root 1 minus x square into y. Hence, but theta is equal to sine inverse of x and plus or minus phi is equal to sine inverse of y is equal to sine inverse of x into root 1 minus y square plus or minus root 1 minus y x square into y. Then we give the next property. Then we give the second property. Cos inverse of x plus or minus cos inverse of y is equal to cos inverse of xy plus or minus root 1 minus x square into root 1 minus y square. Then how to do this equation? Let cos inverse of x is equal to theta 1 and cos inverse of y consider as theta 2. Hence, by inverse function cos theta 1 is equal to x and cos theta 2 is equal to y. Hence, we have sin theta is equal to root 1 minus cos square theta then sin theta 1 is equal to root 1 minus cos square theta 1 and sin theta 2 is equal to root 1 minus cos square theta 2. Hence, sin theta 1 is equal to root, but cos theta 1 is the x, so 1 minus x square and sin theta 2 is equal to root cos theta 2 is the y, so 1 minus y square. But we know that the formula cos theta 1 plus cos theta 1 plus or minus theta 2 is equal to cos theta 1 into cos theta 2 plus or minus sin theta 1 into sin theta 2. Hence, cos theta 1 plus or minus theta 2 is equal to cos theta 1, but cos theta 1 is the x and cos theta 2 is the y, plus or minus sin theta 1 is root 1 minus x square and sin theta 2 is the root 1 minus y square. Hence, we prove this property. theta 1 plus or minus theta 2 is equal to x cos inverse of this x into y plus or minus root 1 minus x square into root 1 minus y square. But we consider theta 1 is equal to cos inverse of x and theta 2 is the cos inverse of y. And so it's equal to cos inverse of xy plus or minus root 1 minus x square and 1 minus y square. Then we give the next point, principal values of the inverse function. So principal values of the inverse function. So first upon consider tan 45 degree is equal to 1. Then tan 225 degree is also equal to 1 and tan 405 degree is also equal to 1. Hence tan inverse of 1 is equal to 45 degree, and here tan inverse of 1 is equal to 225 degree and tan inverse of 1 is equal to 405 degree. Hence we observe that tan inverse of 1 has 3 values. Hence tan inverse of 1 is equal to 45 degree, 225 degree and 405 degree up to so on. Hence tan inverse of 1 has not unique value. It is the multi-valued function. Hence first value is 45 degree. Smallest value which is 45 degrees is the principal value. Hence the smallest value of the angle पॉझिटिव्ह किंवा निगेटिव्ह असेल, आयदर पॉझिटिव्ह or negative, satisfying the relation is called principal values of inverse trigonometry function. Hence here principal smallest value is 45 degrees, the principal values of the inverse function. Then we give the next point, hence the next point is range of principal values. range of principal values. First is principal values of sine inverse of x lies between minus pi by 2 and plus pi by 2. Thus, range of theta is equal to sine inverse of x for principal value is minus pi by 2 less than equal to theta less than equal to pi by 2, and second is range of theta is equal to cos inverse of x for principal values is 0 less than equal to theta less than or equal to pi, and third is range of theta is equal to tan inverse of range of theta is equal to tan inverse of x. The principal value is means this principal value is pi by 2 less than equal to theta less than equal to pi by 2. Okay. Then next chapter we studied examples on this formula.